Hello. Today we're going to have a look at drawing histograms. So we're going to have a recap on how to draw a histogram. Okay, so the first thing to know is that a histogram is not a bar chart. In a bar chart, we are interested in the heights of the bars because the height of the bar represents the frequency. That is not the case in a histogram. We are more interested in the area of the bar because it is the area of the bar that relates to the frequency when we're dealing with a histogram. Okay, we have a typical exam question here. This table shows the heights of some trees in a wood. Show this information in a histogram. So what that's telling me is there are 10 trees which are between the height of 0 and less than 5. There are 32 trees that are between the heights of 5 and less than 15, and so on. Notice that the typical exam question, it starts with two columns. You're given the data, the height of the trees, and you're given the frequency, the total amount of trees. We need to use that information to do some calculations and then draw the histogram. The first step we need to do is we need to create a third column, and we call it class interval, or sometimes it's referred to as class width. And what the class interval is the width of the group of data. So what is the width between 5 and 0 here? What is the width of the group between 15 and 5? So the class interval for the first group would be 5 minus 0, and the class interval for the second group would be 10, 15 minus 5. We work out the class interval for each group. Okay, in a typical exam question, that would be our first mark. Our next step is to now find the frequency density. Frequency density is found by using the calculation frequency divided by class interval. That's how we would define frequency density. Frequency divided by class interval. So if I do 10 divided by 5, I'm going to get a frequency density of 2.0. Notice that I've displayed my answer as a decimal because usually with frequency density, you will be dealing with some decimals. I'm going to go ahead and work out the frequency density for each group by applying the equation frequency divided by class interval. 32 divided by 10 gives me 3.2. 28 divided by 5 gives me 5.6. 8 divided by 5 is 1.6. 9 divided by 15 is 0.6. So now I've got my frequency densities. So the frequency density of 2 is related to all the 10 trees that are between the heights of 0 and less than 5. The frequency density of 5.6 relates to the 28 trees that are between the heights of 15 and less than 20 meters. Okay, so now we're going to use the frequency density. We're going to plot it up our vertical axes, our y-axis, in order to draw the histogram. Okay, the class interval is going to give us the width of the bars, and the frequency density is going to give us the height of the bars when we come to draw this histogram. Okay, so you'll notice that up the y-axis we have frequency density, and it is labeled. Very important that we label our axes. Our highest frequency density in our table is 5.6, which is why I've took the scale of frequency density up to 6 to ensure I can fit all the data onto my histogram. Similarly, our height of trees goes from 0 to 40 meters, which is why I've took the x-axis from 0 to 40 meters to ensure I can fit all the information onto this histogram. So what we are plotting is the frequency density at 2.0, which is here, and we also need to look at the class interval. We're going from 0 to 5. So the width of this bar is going to go from 0 to 5, and its height is going to be 2.0. So we draw in the first bar, it looks like that. Remember, it is the area that we are interested in. If we take the class interval, 5, multiply it by the frequency density, 2, we get the frequency of this bar, the area of this bar, which is 10. So that relates to our frequency, the area of the bars. If I plot my second bar, I have a class interval of 10. So I'm going from 5 to 15. This is going to be the width of my bar. And its frequency density is 3.2. It's going to be up to here in height. It's going to look like that. Again, if I multiplied my frequency density, 3.2, by my class width, which is 10, that's going to give me my frequency, 32. So again, the area, very important. My third bar will look like that. It has a frequency density of 5.6, making sure we're looking at the correct scale on the axes here. Every small square representing 0.2. And again, we're dealing with a width of 5, so it is a narrower bar than the previous bar. Another difference between a histogram and a bar chart you'll see is that there's no gaps between the data here. There's no gaps between our bars here. No gaps at all. You would expect to see gaps in a bar chart. The reason there's no gaps is because the question is dealing with continuous data. If I plot my fourth bar, it looks like so, and my fifth bar is a wider bar. This time we have a class width of 15 and a frequency density of 0.6. When we multiply those two things together, we get an area of 9, which represents the frequency. So there we've completed our histogram. The axes are labeled, our heights are accurate, we're interested in area, and it's a visual representation of the frequencies that we were given originally. Okay, I'm going to do one more example, but I'm going to go through the process a little bit quicker this time. Okay, so we have our data, we have our two columns. The first step we're going to do is we're going to produce a third column, class interval. We might refer to it as class width. We're going to fill in the class width for each group. So I've got a class width of 30, then 20, then 10, and then another 20. Once I've got the class interval, I'm then going to create a fourth column. So I will then apply the equation, frequency divided by class width, or frequency divided by class interval, to find the frequency density of each group. Okay, so in context of the question, we are looking at people at a fairground. So there is 156 people who weighed between 0 and less than 30 kilograms, and they are represented by a frequency density of 5.2. There was 120 people who had a weight between 50 and less than 60 kilograms, and they are represented by a larger frequency density of 12.0. Notice that in the exam questions, the original exam question begins with 2 columns. By the time we're ready to draw the histogram, we've extended the question so it now involves 4 columns. So during your working out, you're adding on an additional 2 columns, class interval and frequency density. Once you've got the frequency density, we can now go ahead and draw the histogram. Class interval is going to represent the width of the bars. Frequency density is going to help us with the height of the bars. Here's my graph paper. Notice that up my y-axis, I've labeled it frequency density. That always goes up the y-axis, and I've went from 0 to 12 because 12 is my highest frequency density. And my data goes from 0 to 80. So again, the x-axis labeled as weight is going from 0 to 80. My first bar will have a class interval of 30. We'll go from 0 to 30, and it has a frequency density of 5.2. So my first bar looks something like that. Again, we're interested in the area. So if we did the frequency density multiplied by the class width, that would bring us back to the frequency of 156, the frequency of how many people were in this weight category. I'm going to use the rest of the data to fill in the remaining bars of my histogram. Okay, and that is my second completed histogram. Few things to summarize. Your exam question will start with 2 columns of information. By the time you're finished your calculations, you should have 4 columns of information. You really need to get used to this equation, frequency divided by class width. You're going to use it a lot when drawing histograms. We also need to remember the basics. Drawing our axes correctly using a correct scale, labeling our axes correctly, remembering that frequency density will always go up the vertical axis, the y-axis. And that is how we draw histograms. Okay, let's have a go at 4 questions. I've put on the screen 4 sets of grouped data. For each question, I would like you to complete the table by adding your 3rd column and adding your 4th column, and then completing the calculations which will complete the table. After you've completed the table for each question, I would like you to produce an accurate histogram to represent the data in the table. You have the ability to pause the video at this point, so please pause the video for as long as it is needed. And for each of the questions, could you produce a histogram displaying the data? Okay, welcome back. I'm going to show you my solution. So at first, I'm going to show you my completed tables. So you can see for question 1, I've started with class width, and then I went on to apply the calculation to work out frequency density. Again, I've continued that with question 2 and 3. So please just be double checking your work, your answers, making sure your 3rd column and 4th column look very similar or look exactly like the columns on the screen. So for each question, the question started with 2 columns, but your completed table should now contain 4 columns of information. The frequency density, of course, is very important. That is going to go up the vertical axis, the y-axis when we come to draw our histograms. Okay, again, you can pause the video at this point if there's any corrections to be made, and then I'll be going through my final solutions of what the histogram should look like. Okay, welcome back if you pause the video. Okay, for question 1, you can see the data in the top right of the screen here. I added class width, I calculated frequency density, I've used frequency density up the vertical axes, I've labeled my axes, very important that we're labeling the variables on the axes, frequency density always being on the y-axis. You can see my frequency density column is in line with the heights of the bars. The widths of the bars are not consistent. Remember, that is a trait of a histogram, that the bars are not necessarily the same width. There is no gaps between the bars. And basically, your histogram should look like this. Number 2, again, data is in the top right corner. I've calculated the frequency density and placed that into a histogram. In my frequency density column, the highest frequency density is 1.4, which is why I've made sure my frequency density axis goes up to at least 1.4, so I know I can fit all the data into my histogram. Again, axes are labeled, and I've just got a little bit of context, a title to the histogram here, a little bit of context that I'm dealing with the age of people. My third histogram should look a bit like this. Again, just make sure that your bar heights, so 1.0 here relates to this 1. And then we've got a 2.4 here with a slightly narrower bar, a 2.4 here, that relates to the 2.4 in this column here. Our highest bar reaches a frequency density of 2.8, which relates to the 2.8 in the table here. The fourth and final histogram looks like this. Again, data in the top right corner. Please make sure your histogram reflects the data in the table. If you've produced 4 accurate histograms from the original questions that you were given, then you've shown some excellent understanding of drawing histograms. Very well done.